they're coming to these resistors. Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. I think we can all agree that this channel is a bit of a vlog. It's like a tech vlog rather than any kind of I'm trying to teach you thing type channel. And often I'm trying to do things like kits or been requested to do kits, and I've done a lot of those in the past and they're really easy to do and they're fun. But I feel sometimes it's just distracting me from my main things that I keep saying I'm going to do and want to do, and that is to actually show you some more of the more in-depth builds, because I tend to do those off camera because it's easier for me to just think on my feet and freeform make something. But then there's a lot of that's the real valuable content there, and I'm not getting to share it with you at all. So I kind of feel it's preventing me sometimes from doing the things I want to do. So I'm using this opportunity to actually get back to something I really want to do, and that is making microcontroller boards like this, and maybe showing you about microcontrollers. And now I've shown you how to solder surface mount, how to maybe make a board like this yourself, maybe end to end, from the whole design to the programming and all of that stuff, all that good stuff. And because I used to have these boards and used to make like 3 different things a day, from stepper motor drivers, servo drivers, LED things, internet controlled gadgets. So you know, it's all relevant stuff now, and just because I did it like 7 years ago when nobody was interested doesn't mean I shouldn't do it again now and actually show people, because now people are aware that this stuff can be done and it is interesting, and they're spending a lot of money on Raspberry Pis and all that sort of stuff. So it's like, okay, look, now let's talk now. You're ready for this info. So I'm just put some batteries in this box now because I just want to check this micro out, and I can't even remember my own pinouts, but there we go, look, he's on power. Curse these big fingers. But yeah, you could see just the LED there. If I zoom in, it's a bit of a stretch for you, I have to admit, when we're zoomed out all the way there. In fact, if I just touch that there you go. It's ready in action. So this thing is basically a microcontroller board, and I can program it there. You see those pins there? That's the in-circuit programmer ports, and then I've got all of these I/O ports that I've labelled V in, ground, 5 volts, and then all of these other channels, and then 5 volts, ground, V in again. So 2 sets of power rails, so you can push that onto a bit of breadboard and off you go. Whereas I don't really use breadboard, I just use Veroboard, which is kind of like breadboard for grown-ups. No, not really for grown-ups, just for people who I don't like using breadboard for prototyping. I just kind of want to make it once, and I'll just attempt to try to get it right first time. That's my motto. It doesn't always work, to be honest with you. Often doesn't work, but at least I'm a bit more committed. So I've got this board that I pulled out of one of these lamps. It's in one of my earlier videos. You can go hunting for it if you're really that bothered. But yeah, these are these sort of LED lamps with RGB lights. And I thought, let's, for a first attempt, hook this board up to this light somehow, yeah, with a ribbon cable, and then get onto the programming and get this to do something with that. And that's it. And then just show you the bit of C code or whatever that does it, and how I program the board and what the in-circuit programmer looks like. And then that'll be like at least a very small end-to-end, very low effort thing to try. So you've got RGB and plus. So let's just check something out here. We've got the plus on there at 5 volts, and I'm going to hold that there, and I'm just going to hold this to the RGB. Not seeing anything, I have to admit, which is interesting. I'm going to turn the polarity round. Yeah, really, I'm not sure how much comes out of the lamps. Let's just use a bench power supply. It might be something like 12 volts. Let's just check this out. We've got something with a bit more gumption. The bench power supply currently is set to 5 volts, and that's not doing it for us. So I'm going to crank it up to, it's at 10 volts now. I'm not imagining this. I did see the reds glow. So it does the reds. They are a bit dim, so maybe it can go a bit higher. So now we're at the full 12, the full Monty. Yes, we've got the green, we've got the blues thinking about it, and we've got the reds going. I'm at 17 volts now. Now the blues are going, greens are going for sure, and reds. Yeah, so there we go. That's a decent amount of voltage required though. I'm going to go offline a little bit and study this to see if there's a way I can make it run off a lower voltage. That way we can give this a 5 volt to let it be powered by the USB 5 volts and actually have it all just hooked up directly that way. Bear with me. So I've been on the computer doing a little bit of research. So the first thing is I had a look for some similar products because I didn't know really what this was. But I found this one which I believe to be similar. This is from Seoul Semiconductor. This is the F50360, and although you can see it's different, it's kind of the same layout, kind of the same pinout, so I figure it's pretty standard. So I went through the data sheet, and just this is 12 pages, but I've taken the one page that I really wanted out, and I've written all of the useful facts here. So just go through them very briefly with you so you can see my thought process and if I'm right or wrong. So you've got red, green and blue, and that may well be a different order on these chips. It doesn't matter. But you can see here the circuit diagram is basically the anode going to the cathode. Ignore these other bits and bobs in here, you don't need to know that. So you've got a device, ultimately you've got a device like that, that's what you can see, and it's got 6 legs. Yeah, you can see the 6 legs, and you know it's doing that. Okay. Functionally, that's all you need to know. It's just basically 3 LEDs in there. But what you need to know here as well, you've got, say, the red, the green and the blue, in whatever order. They are in different orders than this. And what you need to know is the forward voltages are different. So this LED needs 3 volts. The red needs 3 volts to illuminate. Well, that's its maximum, rather. The green's maximum is 4.2 volts, and the blue is 4.1. So they're pretty much as near as each other, really. You don't have to worry about those, and we'll see that in the circuit. And how they're all wired here, from looking at the tracking and looking at the other side of the PCB, it's basically module to module to module. So I went on the computer, and you can see in a little cutaway me clicking away on the computer doing computery things. So I thought, let's write it out, model it out properly. And this is the circuit. So I can even make this available for download if you want to emulate the circuit today. So that's our PCB. This is the circuit from it, and I just want to do the little reminder here. Write that in the top corner again. The red, the green and the blue. And the red 3 volts, 4.2 volts, 4.1 volts. Now I can see without any calculation that our booby board is not going to be able to drive this directly. And the reason being, a booby board's output is it's a sort of, it can vary because it's a 3.3 to 5 volt device, but let's say 5 volts, so it can source 5 volts. Yeah. So that means really you could run one LED directly. Oh yeah, and that's not even to mention the current. We're not even mentioning its ability to do the current, which would be pretty much one LED. So the problem is when you've got them wired in series and it's 3 volts, you can see how many you're going to need. So if you just go for the red, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah? So that's our 12 times 3 volts. Come on then, do the maths, guys. 36 volts. So you remember when we were playing with the bench power supply, it was requiring 12 volts before some of the colours were illuminating and things like that. That's why. So you need a lot of volts here. And I haven't even really gone through these resistors, but it's interesting. So if you haven't seen, oh, by the way, let me just explain. I do apologise if you've not seen this sort of CAD drawing before. You can see the circuit isn't wired up, and that's because I've used nets. So where it comes in, this is this part here are these 4 pins here. Yeah, so that's the red, green, blue and positive. So red, green, blue and positive, these 4 pins here. And you can see they're quite clearly marked, and you can see all these other components are marked too, and that's important. I'll show you why. And they're coming to these resistors, which are resistors on this board, and these are resistor blue 1, resistor green 1, resistor red 1, and they've got 3 different values ranging from 91R, which is another way of writing 91 ohms, through to 181 ohms and 910 ohms. So they are when they goes via the resistor and then out through the resistor to the net called blue in, and then you'll see here there's another net called blue in, and what this means is effectively they are hooked up. But rather than mess up your drawing with loads and loads of extra lines that you don't need, you can just use these nets, and they're almost like hyperlinks within a sheet. Yeah, so they're like little hyperlinks saying this goes to here. So when you go to design your PCB of the software, it actually knows all these things are hooked up, and it will draw it out with all the signals connected. So here where you've got the positive to positive, again, these are hooked up in the drawing. And this is using EagleCAD, by the way. So you can see for each channel then we're going to need a load of volts, and we're going to need between 30 volts and whatever else we decide our upper limit will be, which is the, let's say, 4 volts, right? 4 volts, 48. So yeah, too much, way too much. But so how are we going to deal with this? And I've kind of messed up my drawing a little bit, but that's fine. Is where we've got our blue, green and red. So we're going to have, it's fine, I can just show you. We've got our booby board, which is a microcontroller, and it's got its various outputs, right? What we're going to do is put a transistor between the two. And the transistor looks like this. And excuse the drawing because there is a lot of ridges here on the back of this thing. The base, the collector and the emitter. And how these transistors work, and this is an NPN transistor, and you can, whatever, I'm going to use whatever I can find. I'm not even going to tell you which one it is. It'll just be scrounged up from somewhere. And there'll be a little resistor in here, by the way, a little resistor to resist the current. How these work, these pull whatever is on the collector down normally to 0 volts, right? And you'll normally have your load here, and then you'll have your positive. Had a rummage through the little box, and these are the two options I've got. So I've basically got these, which are a TIP 121 Darlington pair. These are really quite beefy. You can make stepper motor drivers and things, and hence the sort of heat sinks that you can get for them. But I actually also have these, which are the BC548 NPN transistors in this nice smaller footprint. The only limitation on these though, these have a 30 volts collector emitter voltage and a 30 volts collector base voltage. But I think we noticed when we were playing with this that really when I went up to sort of 10 volts they was pretty bright anyway. So for us I think 30 volts are more than enough, because I'm not even sure the spec of these LEDs are quite the same as the ones I found on that data sheet. So we're going to incorporate these into our design. Right, we're ready for doing a test run, I think, here. Get a few bits and pieces. Just to let you know, in terms of this transistor, the collector, the emitter, and the base. Just to remind you of our circuit. This is 0 volts, and our LED, the positive, which will probably be 20 volts plus, and then our base will have a resistor on it and then be driven by something like a 5 volt supply, and we're probably going to use a battery pack for that. So here's our circuit. So this circuit is basically the LED. In the whole grand scheme of things, this is to be considered the LED. So the first thing we need to do is just bend this transistor a bit, just to give us something to work with. And we're gonna basically have it sticking out, because we're going to be probing its emitter. So if you see here, that's the circuit. So the positive end of the LED is here. So we're going to put the other end onto the collector. Let's turn that round. I had that the wrong way there. That would have been bad. Focus, Miss Moneypenny. It's sticking up, straight up, like that. And then we're going to have a couple of common grounds off the emitter leg, because we need to take a ground that goes to the 5-volt supply and a ground that's going to go to the higher voltage supply. So in fact, here's a battery box. I'm going to solder that on right now. Negative. Good. We've got a resistor. We're going to need a resistor because you can see in the diagram here, you want to limit that current into the transistor. If you don't do that, transistor's going to go bang. Yeah, that's looking pretty good. I think we're almost wired up, and we need to have power. So you see this positive here going to the power rail. That's basically this pad here. We're going to solder onto there, and that looks like our blue chain hooked up. So we've got the bench power supply over here. Let's hook up its negative to the negative. Now we're going to hook its positive to the positive, and hopefully it's not going to pull the whole circuit off the table, so just put that there. Our little power supply here is off, so I'm going to turn it on, which is giving us this live on this red, and then I'm going to power up the circuit, so on it goes. So it is live now, and you can see if I touch that with my finger, just that interference alone is enough to trigger that transistor. And you can't see it probably with the naked eye, but that's actually going to be flickering with mains hum. That's me acting as an antenna for the 60 Hertz, and that'll be flashing that. So we've got our 5 volts here, so hopefully if we put it on here, our blue will come on and our transistor won't blow up. And there you go, blue, plenty of blue. I'm just going to hold the transistor, see if it's getting warm, and it's not, so it's good. It's taken the current. So I'm going to turn the voltage up slightly. There we go. We can always be more blue. We're running at 30 volts now, so that's the full Monty. So I'm going to just zoom out, and while that's running, I'm just going to draw out that circuit one more time for you so you can see what we're doing. So we've got now a definite 30 volts is what we're measuring. We've got our chain of LEDs, and they are represented with these little arrows coming off, and that is going into the collector of our NPN transistor, and the emitter is going down here to 0 volts. And then we have from the base a resistor, and the resistor's not huge actually. I should check that. I think it might be a 350 ohm. Sounds a bit small, probably up in the K would be better. And that goes to a 5 volt supply. And that turns out this battery box has a switch, so look, you can actually turn it on and off. Although I think my finger, let me do that. I think you can see it was still glowing, but I think that's just my finger doing that. So, and really, if you're doing this, don't work on live stuff like this. See how it's glowing when I touch it with the soldering iron? Good chance you can blow that out. It should be okay, but there's a chance. So there's a slight glow there, and then if I hook on, bang. So now I've got a 5 volts supply switching, a 30 volt supply. So I don't think I've got time in this video to show you the last hookup, and that's something we'll save for the next time because we'll have to set up all the tool chain for programming these. But essentially I'm going to do the same. So we'll replicate 3 of these. So we'll have the red, the green and the blue, and all we'll have, this side of the circuit will remain the same, even the resistor. And instead of 5 volts coming from a battery snap to a switch, which is kind of what we have here right now, yeah? Ignore that little bit in the middle. We're going to be putting a microcontroller, and 3 pins of the microcontroller will be toggling that input. And it's going to be doing some cool things. So not only can we just turn on and off the red, the green and the blue, it'll have them all come on together or off together. I'm just going to try to demonstrate, and I'll probably break the switch, but if you can see what I'm doing here, yeah? You're basically flickering it. What we're going to do is we're going to use the microcontroller to change the pulse width. So if we have the red, the green and the blue, you could see if the red is on all the time, that's just the red is on and while the green and blue are off. Yeah. But what we can do is if we want to say make the red dimmer, we can actually do that. Yeah. And we can change how quickly we do that. It can be very quick, very long, so it can flash, or it can be zzz, and that changes the brightness of each one. And then if we do that in combination with each other, different channels, you can basically get different colors, and that's how you have these multicolor changing lights. So that's what we'll be doing next time. I hope that's been of some use to you. Please like, subscribe and share if you're that way inclined, and as ever, thank you for watching.